Good morning, students. So, have you all completed the homework problem? The serial communication problems, the transmission and reception. So, according to this problem statement, you have to write an assembly language program to receive bytes of data serially and put the data in P1, okay? And the baud rate is here 4800, okay? Is there anyone ready to explain this problem? Students, please interact. Otherwise, I will call out your numbers. So, have you completed or not? Yes or no? Yes, okay. What about others, other students? Please kindly respond. So, have you completed both transmission and reception, embedded C in transmission, and assembly and embedded C for reception? Alauddin, can you explain that reception problem? You can explain that.
Okay.
First, you explain the steps to be involved, steps to be.
First, we need to insert timer mode register.
Okay.
First, storing inserting timer 1.
Okay.
And the baud rate is given is 4800, so we have to insert higher order timer as FA.
Okay.
Next, we have to insert a serial controller register, ma'am.
Okay. What is the value to be loaded?
8 bit and 1 stop bit, so 9th bit.
Okay. What is the value? Value of SCON? 50. Okay. So what is the
next? Next we have to set the TR1 bit timer.
Okay.
Then we have to check the receiver. Receiver
interrupt. RI.
Receiver interrupt flag. RI between serial card register. If it set, we have to move the value from S buffer register to accumulator. Then we have to clear the pen.
Okay, very good.
Then we have to clear
the RI flag. So after setting all the values, after initializing all your initial values, you have to monitor your RI flag, whether the data byte is received or not. Suppose if the S buffer is full, means the data byte is received. So that time your RI is set to 1. So which means that your data byte is received and that will be available on your S buffer register. So now we have to clear the RI register and move the data from S buffer to the corresponding port. Okay. So move T0, #20. Timer 1 in mode 2. Next, set the baud rate. You have to Load the TH1 value with FA for 4800 baud rate. Next, initialize your SCON register hash 50 mode 1 8-bit UART mode. Okay. So next you have to start your timer in order to generate your baud rate. So after that we have to monitor our RI flag continuously to monitor the reception. Okay. So L1 jump no bit RI comma L1. So continuously we have to monitor RI flag. If RI is set to 1, the data will be available on S buffer register. So we have to move that register to accumulator. After that, move accumulator content to P1 and clear RI SJMP L. Continuously monitor the receive interrupt. So in previous case in transmission, after setting your TR1 bit, we are transferring, that is moving the character to S buffer, and after that we are continuously monitoring TA flag. Here it's a reverse operation. First we have to check the RI flag. If RI is set means the character is completely received and that will be available on S buffer. So we have to transfer that content from S buffer to some other general purpose register. Okay. After that, you have to clear the RI. Okay. Any doubts regarding this? Is that clear? Students, is that clear? Vineet?
Sir.
What is RI? What is receive interrupt flag? What is the purpose of RI? See, you have to listen the classes carefully because everything is reflected in your lab. So your second cycle is completely based on embedded C. So without knowing these concepts, you are not able to understand the embedded C concepts. Do you have any idea about RI, Vinith?
No, ma'am.
No. Simply you are coming and going. Not at all listening. Yalini. So next is mid semester ரொம்ப டஃபா தான் evaluate பண்ணுவேன். நம்ம சிம்பிளா அப்படியே objective கிடையாது. It's a descriptive test. So Friday you are going to write the test. I am planning to conduct the test on Friday from 3:30 to 4:30. லேப்ல நீங்க எப்படி ஆன்சர் பண்றீங்களோ அதுக்கு தான் தியரியில மார்க். ஞாபகம் வச்சுக்கோங்க. இப்போ நீ எம்பெடட் சிக்கு நான் ஒரு வைவா கண்டக்ட் பண்ணுவேன், அதை வச்சுட்டு தான் மார்க். நீங்க அப்படியே ஜாலியா இருக்காதுங்க. இட்ஸ் வெரி இம்பார்ட்டன்ட் பேப்பர் ஃபார் யுவர் பிளேஸ்மெண்ட்ஸ். யாழினி ரிமூவ் பண்ண போறோம் பாருங்க மீட்டிங்ல, சும்மா வந்துட்டு போறவங்களை எல்லாம் சொல்லுங்க பார்க்கலாம். யாழினி சொல்லுங்க, ஆரைனா என்னம்மா?
Reverse interrupt flag, ma'am.
Receive interrupt flag. What is the purpose of receive interrupt flag?
Byte has been received, ma'am.
Louder, please.
டேட்டாவை பிக் பண்ண யூஸ் பண்றோம் மேம்.
டேட்டாவை பிக் பண்ண யூஸ் பண்றோம். எங்க இருக்கும் அந்த டேட்டா ஆஃப்டர் ரிசெப்ஷன்? Nagita, can you explain that?
Yes, ma'am.
What is the RI? What is the purpose of RI?
Yes, ma'am. Ma'am, RI is also called receive interrupt flag, ma'am.
Yes.
When this indicate when S buffer is full, ma'am. That is, bits have been loaded into S buffer, ma'am.
S buffer. Okay. What is the purpose of TI?
Ma'am, TI is also called as transmit interrupt flag, ma'am. And
Okay.
this indicates when our S buffer is empty, ma'am. When S1 is 1, it indicates that S buffer is empty, ma'am.
Okay. Okay. Thank you.
Yes.
So this is the embedded C program for transmission. So here you have to initialize, that is specify your header file for 8051 microcontroller, and inside main tmod value has to be initialized. Next th1 scon. Next you have to convert that assembly into embedded C. That's all. Next, start the timer by writing tr1 is equal to 1, and inside while you have to move the character into S buffer. Instead of jump no bit, here you have to use while 1 to monitor TI flag continuously until TI becomes 1. So when TI is equal to 1 means comes out of the loop and clear the TI for next transmission. Okay. So this is the embedded C program for to transfer the letter A serially at 4800 baud rate. Okay. So reception. So first 4 steps are very similar to your previous one. Here you have to define your unsigned character for storing your data. Okay. So inside while you have to monitor your RI. When RI set to 1, you have to transfer the character from sbuff to the variable, next variable to P1, and next make RI is equal to 0. So that's all about your serial communication. So try out all these programs in Kale Microvision. Okay. So next unit 3 is peripheral interfacing. Okay. So what is the meaning of this term interfacing? Why it is needed? So in this unit, we are going to cover programmable peripheral interface 8255, keyboard display controller, programmable interrupt controller, and some of the case studies related to this IC 8255, 8279, and 8259. So here we are going to concentrate on traffic light control, interfacing keyboard, and seven segment already we have covered in laboratory, and LCD display. Okay. So what is the meaning of this term interfacing in microcontroller based systems? Any idea? Linking two devices to be connected. Okay, to connect with very good, to connect with external hardware device, to connect external device. So the process of interconnection of external devices to the microprocessor or microcontroller is called interfacing. Okay, and external devices, for example, such as your keyboard and display, etc., cannot be directly interconnected to the microcontroller because of two reasons. Okay. So this is the block diagram of your complete microcomputer based, that is microcontroller based system. We have CPU, standalone CPU, and all the devices are connected either internally or externally. Okay, so this is a general microcomputer based system. In case of your microcontroller, all these things are integrated internally. Okay. So the peripheral devices can communicate with processor or controller through this interface circuitry. So the reasons are the generally, normally the peripheral devices are slow devices, okay? So the speed of microprocessor or microcontroller is not compatible with the speed of external devices. So your microcontroller is faster than any external device. So to synchronize the operation between peripheral device and my CPU, we have some external interface circuitry for synchronizing the operation of peripheral device with CPU. So that is the one of the reason. That is speed of microprocessor and microcontroller is not compatible with the speed of external device. Second reason is that the electrical characteristics, that is such as voltage requirement, current rating, etc., are not same for the microcontroller and the external devices. Okay, so to synchronize the activities or synchronize the operations between your peripheral and CPU, we are in need of some interfacing IC. It is like a middleware between your processor and peripheral devices. So these intermediate devices are used to interconnect your microcontroller with peripheral devices. So such devices are programmable I/O devices. So this interfacing circuitry or IC are programmable I/O devices along with I/O functions such as that is they can also perform many other functions such as time delay, interrupt and counting. Okay. So some of the programmable devices that can be used with your microcontrollers are A255, Programmable Peripheral Interface. So these are the programmable devices that can be interfaced with your 8085 processor, 8086 and 8051. Okay. So the first one is the A255, it is a programmable peripheral interface, and second one A251. So this is called USART, Universal Asynchronous Synchronous Receiver Transmitter, and third IC A253. It's a programmable timer or counter. In case of 8085 and 8086, so these microprocessors don't have internal timers. So using this interfacing IC, we can implement our timer and counter operations. So 8253 is the programmable timer and counter, and A2 next IC. A279 is keyboard and display interface. And fifth IC, A257, it is a programmable DMA controller. And sixth one is the programmable interrupt controller, A259. So in third unit, we are going to cover this A255 and A279 and A259. All these ICs are manufactured by Intel. Okay. So A255 is a programmable peripheral IC, 827 is the keyboard or display controller, 8259 is the programmable interrupt controller. Okay. So the first IC is 8255, it is a programmable peripheral interface. Actually, why it is needed means your 8051 has limited number of I/O ports. So we have 4 ports, port 0, port 1 and port 2, port 3. So we have 32 I/O pins. So it's a limited number of I/O. So if we want to connect more number of I/O devices, so intermediately we can use this 8255 between your external device and 8051 to add parallel, that is to expand the port handling capability. So one solution is to add parallel interface chip. So that is A255. It is a programmable peripheral interface. So it is used to expand the number of parallel I/O ports. And again, in case of 8051, your I/O port does not have handshaking capability. So any idea about handshaking? What is handshaking? So what a handshaking signal? Any idea about handshaking? So prior to data transfer, there is a signal called handshaking signal. So that is exchanged between your microprocessor or microcontroller and peripherals. Okay. So in order to start the data transmission between your controller and peripheral device, so some of the signals are exchanged, transmitted back. Manushree, it's the exact answer. Okay. So the signals are exchanged between your devices, that is your I/O device and the microcontroller. And exact definition, please note it down. It's a very important concept in this unit. So signals are exchanged between I/O device and port, your microprocessor and microcontroller port, for checking or informing various conditions of the device. Okay. So that capability is not provided in 8051. So 8255 can add handshaking capability to 8051. So here 8255, we have 3 ports, port A, port B and port C. Okay. So the port C is divided into 2 ports, PC0 to PC3, PC4 to PC8. And port A is a 8-bit parallel I/O port. Port B also 8-bit parallel I/O port. And port C 8-bit. It is divided into upper and lower. It is separated into PC lower and PC upper. So we have 24 I/O port lines. So your 8051 I/O capability can be expanded while interfacing your 8255 IC to 8051 microcontroller. Okay. So which can control 24 output signal. It is a 40-pin IC. Okay. We will see one by one. So in this 8255 architecture, it is operating in 3 modes, that is mode 0, mode 1 and 2. Okay. So mode 0 is a simple I/O port. Okay. And mode 1 is the handshake I/O port and mode 2 is bidirectional I/O port. Okay. So we have 3 ports, port A, port B and port C. So here port A can be programmed to work in all the modes, that is mode 0, mode 1 and mode 2. Mode 0 is a simple I/O, mode 1 is the handshaking mode and mode 2 is the bidirectional I/O port. So port A can be programmed to work in any of the modes, that is mode 0, mode 1 and mode 2. And port B can be programmed to work either in mode 0 or mode 1. Is that clear? So port B can be programmed to work either in mode 0 or mode 1 as input or output port. Okay. And the port C have different assignments depending on the modes of port A and B. So port C completely depends on the modes of port A and B. For example, if port A and B in mode 0, suppose if both the ports are operating in mode 0, so at that moment port C will perform following operations. So the operations are, it can be configured as 8-bit parallel port. That is the one of the function. Okay. And second function, it can be configured as 2 numbers of 4-bit parallel ports, that is PC lower and PC upper. And individual pins can be set or reset. Okay. So it will perform 3 functions if port A and B in mode 0. So 3 configuration can be done based on your port C. So it can be configured as 8-bit parallel port or 2 numbers of 4-bit parallel ports. Individual pins of port C can be set or reset. Suppose if port A and B in mode 1 or 2, that case your port C will perform these two operations. Either it will provide handshaking signal or it can be configured as IO lines. Okay. So if port A and B are programmed in mode 1 and 2, then some of the port pins are used for handshake signals, and then remaining pins can be used as IO lines or individually set or reset for control application. So that's all about your IO port. So we have 3 ports, port A, port B and port C, and operating modes, mode 0, mode 1 and mode 2. So port A can be programmed to work in mode 0, mode 1 and mode 2, and port B can be programmed either in mode 0 or mode 1. So your port C have different pin assignment depending on the modes of your port A and port B. Suppose if port A and B is operating, port A and B are operating in mode 0, so that time your port C can be configured as 8-bit parallel port, 2 numbers of 4-bit parallel port, and individual bits can be accessed. Okay. Suppose port A and B are configured to work in mode 1 and mode 2, that case your port C, some of the pins are of port C are used for handshake signal or IO lines. Okay. So here you can see in mode 0 is a simple IO. So what are the ports are involved? Any of port A, B, C lower, C upper can be programmed as input or output. Okay. In mode 1, IO with handshake. Here only port A and B can be used for IO. C will provide the handshake signals. So port C are used for handshake signal in mode 2. Okay. Mode 1. Mode 2 is a bidirectional with handshake. Here port A is only involved. C will provide handshake signals. And fourth mode is the bit set reset mode. It's completely depends on the control word of 8255. I will explain that later. So only port C is involved in this mode. Allows single bit manipulation, that is set and reset the individual bits for controlling applications. Okay. So mode 0, all the ports are involved. Mode 1, only port A and port B can be configured as IO lines, and that case your port C will provide handshake signal. In mode 2, only port A involved and port C are used for handshake signal. Okay. So this diagram represents basic mode definitions and bus interfaces. So first mode is the basic IO mode. So here all the ports are involved. Your port B, that's VB0 to VB7, and PC lower, that port C lower, and port C upper, and port A. So all the ports are configured as input as well as output. Okay. Port A, B, C, all the ports are involved in mode 0. In mode 1, port A and B can be programmed either as input or output. Port A and B can be programmed either as input and output, and your port C pins are used for handshake operation. Okay, here mode 2, port B is not involved in this mode, only port A involved. And 5 pins of port C are used for handshake signal, and remaining pins are used for IO lines. So 3 lines of port C, that is 5 lines of port C, 5 pins of port C are used for handshaking, and remaining for IO operations. Is that clear? Is that clear? So do you have any doubts in modes and your port assignments? So in mode 0, all the 3 ports can be programmed either as input and output. Please remember, in mode 0, all the 3 ports can be programmed either as input or output. In mode 1, only port A and B can be programmed either as input or output port. Okay. And mode 2, it will perform both read and write operation. Only port A can be programmed to work in mode 2. Okay. So in this case, simple IO mode, it will provide simple IO operations, no handshaking involved here. So simply it will transfer the data from microcontroller to specified IO device. That is, it will perform both read and write operation. So 2 8-bit ports and 2 4-bit ports. That is your port A and port B 8-bit ports. Okay. Port A and port B. So all the ports can be programmed to work either as input or output. Okay. So 2 8-bit ports and 2 4-bit ports. So any port can be input or output. Here outputs are latched, inputs are not latched. So the latching, the meaning is the memory storage. So latch is an electronic component, electronic device or a level triggered flip-flop. So it can serve as a 1-bit memory for temporarily holding the data. So in case of outputs, we can store our data using your flip-flops. Inputs are not latched in case of your mode 0. Next, mode 1. In this mode, input or output transferred by handshake. That is, handshaking scheme is possible in this mode 1, but interrupt is not at all possible. Interrupt-driven data transfer is not at all possible in mode 1. Okay. So the definition is handshaking signal is used to transfer data between those devices whose data transfer rate is not same. Okay. So several messages are communicating between your microcontroller and IO port. After that, the connection is established. Okay. In mode 1, port A and B use the lines on port C to generate or accept these handshaking signal. So mode 2 is a bidirectional mode. So here the processor that is controller or processor can perform both read and write operations with an IO devices connected to a port in mode 2. So here only port A can be programmed to work in mode 2. So 5 pins of port C are used for handshake signal. So this mode is used primarily in applications such as data transfer between two computers. Okay. And this will support interrupt. Interrupt functions are available. Interrupt generation is possible in mode 2. So this is a mode summary for 8255. You look at this table. Port A can be programmed to work in all the modes. Mode 0, mode 1 and mode 2. Port B in mode 1 and mode 0. Port B is not involved in mode 2. Port C in mode 0, it can be configured as either as input or output. In mode 1, it will provide handshake signals. Similarly, mode 2, it will provide 5 pins are for handshaking and remaining for IO lines. Okay. So this is a pin configuration of Intel 8255 programmable peripheral interface. So here the first one is the reset, and second one is the chip select signal, the read, write, 2 port addresses, 3 ports, VCC and ground. Okay, so we have port A, port C, port B, and 8-bit data bus is involved in 8255 operation. Your microcontroller can communicate with 8255 through this data bus, that is from D0 to D7. It is a bidirectional one. And all the ports are bidirectional. Suppose this signal, it's an input signal, and read bar is an active low. Okay. So this signal is coming from your microcontroller. So this signal is provided by your microcontroller. Okay. Similarly, write bar is the active low signal, and this signal is provided by your microcontroller. So we have 2 address lines, that is A0, A1. So this A0 and A1 and chip select. Your chip select must be 0 to select your 8255. So these 3 signals are used to select the internal devices of 8255. When these 3 are 0, your port A will be selected. 0001 port B, 010 port C, 0111 control port will be selected. Okay. So this is the internal block diagram of your 8255. So the ports are grouped as group A and group B. Group A, group B. So group A has port A and port C upper. Port A and port C upper, and these two ports functions are controlled by this group A control. So this is connected to this control logic. Okay. So port A and port C are controlled by group A control. And next one is the group B. So group B has port B, that's port B and port C upper, and these two are controlled by group B control. So all the devices are connected through internal data bus. Okay. And here we have data bus buffer. All your data transfer can be done between your microcontroller and 8255 through this D0 to D7. The data transfer can be done through D0 to D7, that is data bus. And this is the read and write control block. So this will provide control signals. So all the signals are coming from microcontroller side. And this side, your external devices are connected. So your left hand side, let's assume your left hand side, your microcontroller is interfaced, and your right hand side, your IO devices are interfaced with 8255. So this is like an intermediate device between your microcontroller and external devices. So read bar, first signal, control signal is the read bar. So this control signal enables read operation. Okay, when this signal is low, microcontroller reads data from the selected IO port. So this will perform simple read operation. So this signal is activated when this line goes low. Okay, so that time your microcontroller reads the data from the selected IO port of 8255. Similarly, for write operation, this control signal enables write operation. So when this signal goes low, your microcontroller writes into selected IO port or control register. So we have 4 internal devices: port A, port B, port C, and control registers. So based on this signal status, it will perform write operation. And A1 and A0 and CS bar. So these are device select signal. So already I have explained this one. So these three are device select signal. So CS bar is connected to the decoder in the system. Okay. So A0 and A1 are generally connected to A0, A1 line of your microcontroller. Okay. So these three signals are used to select your ports and control register. Here we have chip select signal. So 8255 can be either memory mapped or IO mapped. So any idea about memory mapped IO mapping? You might have studied in 8086 architecture. What is the difference between IO mapping and memory mapping? Any idea about it? What is the difference between memory mapped device and IO mapped device? I want some answers from you. What is IO mapping? It's a very basic definition. I think you might have studied in either architecture or 8086, computer architecture or 8086 architecture. Memory map share the memory space with external memory. Very good. Next, IO mapping. So memory mapping means your IO device and memory both are treated as memory device. Okay. In case of IO mapping, IO devices are treated as IO device and memory is treated as memory. Okay. And in memory mapping, all the operations are controlled by memory read signal and memory write signal because your IO device is configured as memory device. So all the operations are controlled by memory read and memory write. In case of IO mapping, all the operations are controlled by IO read and IO write. So in case of your that is memory mapping device, we have to use memory related instructions. Okay. So all the instructions related to memory can be utilized for the data exchange between processor and IO device. So in case of 8051 architecture, for accessing data from 8255, we have to use move X instruction. So that is the meaning. So 8255 is treated as a memory in case of your 8051 architecture, if the device is a memory mapped device. Okay, is that clear? Is that clear? It is a very important concept in interfacing devices. Is that clear? So that's all about your functional block diagram. Okay, so we have two groups, group A and group B. Group A has group A port, that is port A and port C upper. Group B has port C lower and port B, and all the data transfer can be done by using this bidirectional data bus. So this will provide the connection between your microcontroller and 8255 IC, and this block will generate will accept control signals generated by your microcontroller. Read bar is active low. This will perform read operation, write operation. CS bar, A1 and A0 provides, that is these three signals are device select signal. And what is the purpose of this reset? So it's an active high signal. It clears the control register and set all the ports in input mode. If the signal is high, it clears the control register and set all the ports in input mode. Okay. So it's a control signal table. So here A0, A1 both are 0, 0. So read bar is 0, write bar is 1. So according to this combination, Read operation is activated or write operation is activated? Please tell me. So look at the first combination. So first combination, read will be activated, read operation, since it is a active low signal. And CS bar is 0 means your 8255 is selected. So here IO operation, the data is transferred from port A of 8255 to microcontroller. So the data transfer is from your 8255 to 8051. That is the meaning. So the port A data is placed on the data bus of microcontroller. Next 01, read bar is, that is read operation is activated, write is disabled, your chip select is activated. So the data is transferred from port B to data bus. Next 10 combination, read is activated, write is disabled, your chip is selected, data is transferred from port C to data bus. Next, again 3 combinations for write. Write operation is activated for 00, 01 and 10. So here data transferred from data bus to port A, data bus to, that is controller to 8255. Controller to 8255. Next, last combination 111, write operation is activated. So data was transferred from 8051 to the control register of 8255. So please note down the combination. This combination is very important to program your 8255. Okay. So these 3 are device select signal: A0, A1 and chip select. Based on that, your port A, port B and port C will be selected. So next, control words of your 8255. So 8255 has 2 control words, one for specifying IO operation and another for bit set and reset mode of port C. So 2 control words. One is IO mode set control word. IO mode set control word. Second one is the BSR control word. So control word is nothing but it will control the operation of 8255. So that control word is provided by your 8051. Okay. So we have 2 control words, IO mode set control word and another one is the bit set reset control word. So this IO mode set control word is for specifying IO function, and this is for bit set and reset the individual port C pins. So this is mainly for port C. Okay. So here the bit D7 control register specifies either IO functions or BSR function, bit set reset function. Suppose this D7 is 1 means the bits D6 to D0 determine the IO functions. Okay. So the control register different, both the control words are written in the same control register. Is that clear? So both the control words, IO mode set and BSR control, both the control words are written in the same control register. So the control register differentiate them by the value of D7. Okay. And the bit set and reset control word does not affect the functions of port A and B. So it's only for port C. Suppose if D7 is 1, okay, the bits D6 to D0 determine IO functions. Okay. Otherwise, it will determine the pin of port C to be set and reset. Okay. Is that clear? So this one defines your IO mode and BSR mode. Suppose if D7 is set to 1, let's assume D7 is set to 1. So D0 to D6 will determine the IO functions. Suppose if this bit is 1, your port C lower is configured as input, otherwise output. Similarly, 1 means it configured as input, otherwise output. Okay. In mode selection, so here your port B and port C involved in mode 0 and mode 1. So 0 means mode 0 selected, 1 means mode 1 is selected. And here mode selection, this block, port A and port C upper involved in mode 0, mode 1 and mode 2. Okay. So 1 means it is configured as input, otherwise output. Similarly, 1 means input, 0 means output. Mode selection 0, 0, mode 0 is selected, 0, 1, mode 1 is selected. 1 undefined is equal to mode 2 is selected. Any doubts? Any doubts, no? So this is the complete interfacing diagram of your that is 8255 with 8051. So here 3.7 will provide read bar control signal and 3.6 provides write bar control signal. So these two signals are connected to read bar write bar of 8255. And pin 2 point, that is port 2.7, that is nothing but your A14, address bit A14. So that is inverted and connected to the chip select pin of 8255. And this block you have already know about this, that is using ALE signal, we are demultiplexing the address and data lines of port 0. So port 0 will provide multiplexed address and data line. So that demultiplexing can be done by using this circuit. And output is here according to 8255, A0, A1 will be generated for device selection. For device select signal, chip select signal, A0 and A1. And 8-bit data pins are connected to your port 0. So this method of connecting I/O chip to CPU is called memory mapped I/O. So this is act like this particular IC, it acts like a memory chip. Okay. So use memory space to access I/O. So here we have to use move X instruction to access 8255, port A, port B and port C. Okay. See, so in this diagram, so using this diagram, we have to find the I/O port address assigned to port A, port B, port C and control register. Okay. So according to this diagram, only A14 is involved for chip selection. So this signal must be 1. Okay. So A15 is undefined. A15 is undefined. So 8051 provides 16-bit address. Okay. So we have to identify the address for port A, port B and port C. So here A15 is undefined, A14 is the chip select signal for all the 4 devices, your port A, port B, port C and control register. So this signal must be 1 and remaining all the signals are undefined, not used. Okay. And A0 and A1 are device select signal. So 0, 0 means port A selected, 0, 1 port B, 1, 0 port C, 1, 1 control register. So what is the value? So put zeros for all the X. So 400. So that is the internal address of port A according to this interfacing diagram. Okay. And port B 4001, port C 4002, for control register 4003. Okay. Is that clear? Can you understand the memory mapping of this particular interfacing diagram? Can you understand? See, A14 is involved. This A14 is used to generate chip select signal. So we make this A14 is 1 for all the combinations. Remaining all address lines are not at all used. And device select signal combination 0001 1011. So based on that, addresses are assigned to your port A, B, C and control register. So while programming your 8255, according to this interfacing diagram, we have to use this as an internal address of your port A, port B, port C and control register. Okay. So next one, program 8255 for ports A, B, C to be output ports. So you have to find the control word for this one. That is, you have to configure all the ports to be output ports in mode 0. Please find out the answer. So you have to configure all the ports as output port in mode 0. What is the answer? Just you apply the values here and find out the answer. Can you understand the question? You have to configure all the ports as output port. So what is D7? What is D7 here? 1 or 0 for IO configuration? Please tell me. 1.
1, ma'am.
1. And next D6, your mode 0 is selected. So D6, D5 are 0. Okay, D6, D5 are 0. And D4 must be 0. Okay, D3, 0. And D2, 0. D1 also 0 output. Okay, D0, 0. So what is the answer? 80. 80 is the control word. For this particular interfacing diagram, the control word is 80. So program 8255 for port A, B, C to be output ports. Okay. And also the problem statement given here is write a program to send 55 and AA to all the ports continuously. Okay. So already we have calculated the address. Okay. Based on this device select signal and along with your all address lines. So we have to use this address for transferring the data between your microcontroller and 8255. Okay. So the control word is 80. So the control word is 80. So you have to latch this 80 into control register. What is the control register address? 4003 is the control register address. So first define this 80, that is move this 80 to accumulator and initialize the address, control register address to DPTR. Next step, you have to move this control word to 4003. So 80 is written into control register. Now all the ports are configured as output ports now till this line. So you have to find out the control word and write the control word into the corresponding register. So based on the interfacing diagram, the internal address of control register is 4003. Okay. So you have to write the control word into 4003. Now all the ports are configured as output ports in mode 0. Next, what is the problem statement here? You have to send 55 AA to all the ports. That is, you have to send 55 to 4000, 4001, 4002. Similarly, AA to 4000, 4001, 4002. Okay. So first define your data, that is move this 55 to accumulator, and this address is the port A address, and write 55 to port A first. Okay. Next, increment DPTR. So it's pointing 4001. Move 55 to 4001. Next, increment DPTR 4002. That is your port C address. Move 55 to DPTR. Okay. Next, what is the next step? You have to send AA to corresponding ports, port A, port B, port C. So complement A means your accumulator holds AA. Now your accumulator holds AA. Call the delay routine. Again repeat the steps. Next you have to move AA to port A, port B and port C. So in this way we can program your 8255 ports either as inputs or output. Please note it down. So first you find the control word based on the IO configuration, and next move this, initialize your DPTR. Okay, that is load the control register port address. Next move the value to DPTR, and according to the problem statement we have to send 55 and AA to port A, port B, port C. So define the address and send the value one by one to port A, port B and port C. Any doubts? So next class we will see about the remaining thing, and bit set reset mode. Okay. So next one is the different. So chip select signal is generated by using this logic diagram. So based on that we have to calculate the internal address of port A, port B and port C. So I am planning to conduct a special class tomorrow, okay, from 12 to 12:30. 12 to 12:30 to complete this programmable peripheral interface. And Friday you will be having your test in unit 2. So 15, that is objective test 15 marks and descriptive test 15 marks. So totally 30 marks. That is 1.5 hours test from 3:30 to 5 o'clock. Okay.